Now here's where it starts to differ from the moon. Mercury does have a weak EM field. By weak we mean 1/100th of the Earth. Now, it's an EM field we think is caused, or at least the Earth's we think is caused by the outer core, which is liquid metal, right? And the liquid metal is spinning around. Okay, so the liquid metal and spinning creates an EM field. Well, Mercury rotates too slowly, so it doesn't really have the spin. And we're not even sure Mercury has a liquid metal core. Well, okay. So if it doesn't have a liquid metal and it's not spinning fast enough, how does it have an EM field? Now maybe this is why it's so weak. There is maybe something down there and spinning so slowly that maybe something's happening, or maybe we need a new theory altogether. Not entirely sure. Now, its magnetic field does the same thing as the Earth's magnetic field. It deflects solar winds, it brings it to the North and South Pole, and like I said, we're not entirely sure how it's formed. Just that it is there. We've seen it. Now, this is something else interesting. It has a large iron core. Right? When you consider the size of the planet to the size of the cores would actually be the biggest out of all the planets. Okay, I know Mercury is the smallest planet, but when you consider the sizes of the size of the planet to the size of the core, it has the biggest core. So 60% of the planet we think is actually the core. And it has a large density. Maybe this could have something to do with the EM field because the metal portion is so big. No idea. But if you look at the comparison here, a little picture, Earth and Mercury, right? We have a pretty darn good sized core. But if you look at Mercury's core, it's almost the entire planet. It's kind of ridiculous. All right, so Mercury had to have some sort of geologic history because there is evidence of volcanic activity, more so than volcanic activity on the moon. But for the last 4 billion years, it's just basically been a sitting ball of iron and rock. It didn't really develop plate tectonics because it cooled too fast. So no moving plates. But the first half billion years, right, because it should be about 4.6 billion years old. So the first half billion years, there was melting, there were meteorites, it was cooling, it had a thin crust, it had volcanoes, so there was something going on. Right, and like I said before, I do think that lava actually did help to fill up some of these craters. And like I said before, they do have these huge cliffs, which we think is caused by the cooling of the planet itself, or the cooling of the core, because the core is most of the planet anyway, which caused everything to shrink and have these cracks in them. Alright, so we're getting near the end of Mercury. And this picture is not in your textbooks, with that I would include it here. It's basically just a summary of Mercury. You can see the spin, you can see the core, you can see the crust, you can see the temperature, the EM field, a couple different craters on it. Just a cool little picture. On the next slide is a little video about Mercury and its orbit. And it's really cool, especially right at the end when it starts to show you how it orbits around the sun. It's very impressive, and I wish I could get into that more, but honestly I can't, for multiple reasons. But it's incredible the stuff that we can actually see and detect, and kind of defies everything. It's really neat. Watch the next little video.
In an otherwise violent universe, we've hit the orbital jackpot. Yet chaos is never far away. Even within our solar system, there are extreme and violent orbits where life could never survive. Mercury, the closest rock to the sun and the smallest planet in the solar system. Its orbit stretches into an oval shape. At its furthest point, Mercury is 43 million miles from the sun. But at its closest point, it's just 28 million. This close in, it's hot.
800 degrees Fahrenheit, hotter than a baker's oven. Also, because there's very little atmosphere on Mercury, you'd choke. And because there's no air to speak of, the blood in your body would boil and it would burst your skin. You would literally explode on the surface of Mercury.
But the temperature can also fall to 300 degrees below zero, 3 times colder than the coldest place on Earth. Mercury has the most extreme temperature variations of any planet in the solar system. But it's also proof that orbits don't just loop. With each revolution around the sun, Mercury's path shifts. Over thousands of years, the planet follows a daisy pattern. At the other end of the solar system,